Welcome back. In this tutorial, we will solve a job assignment problem with profits, capacity limits, and logical constraints. We will build the math model first and then write the GAMS code and finally see the optimal solution. Let's start. The contractor has 5 jobs and 2 workers. Profits depend on which worker gets which job. We want to maximize total profit, but there are rules. Each worker can do at most 2 jobs. Each job can go to at most 1 worker. Job 4 is mandatory. Job 1 and 3 can't go to the same worker, and job 2 can go to worker 1 only if job 4 goes to worker 2. So before starting, we can see that there are many logical constraints, conditions where the activation of one means that the other cannot be respected. So how do we solve a problem like this? First of all, we identify the set that are E, the set of workers, V1 and V2, and J, that are the set of jobs, 1 from 1 to 5. Then we build the profit table that hits the profit for assignment E and J. This table shows the profit if a worker does a job. For example, if worker 1 does job 2, the profit is 9. If worker 2 does job 5, the profit is 15. Once we build the table, we put the scalar n max number of jobs that can be done by each worker. That is 2. The decision variables, the most important, are y, ej, that equals 1 if worker E does job J, else 0, so it's a binary, and z is our objective variable. About the objective function, we can say that our objective is to maximize the total profit. This is simply the sum of profits of all chosen assignments. About constraints, there are different parts that we need to take into account. This is the 5 constraints that we need to respect, and here we are going to see them one by one. The first is the worker capacity. Each worker can do at most 2 jobs, so for every worker, the sum of jobs assigned cannot exceed 2. The second one is that each job can be assigned to at most 1 worker, so for every job, the sum across workers cannot exceed 1. So here we have the mathematical model, and here we have the GAMS code. Other condition, job 4 must be done. So job 4 is mandatory, and to represent it, either worker 1 or worker 2 must take it, but not both, either one or the other. About job 1 and 3 rule, we need to say that job 1 and 3 cannot go to the same worker. So for each worker, at most one of these 2 variables can be 1. Here always the mathematical model, and here the GAMS code. Let's go on. The conditional rule, that is also the last one, says that job 2 can be assigned to worker 1 only if job 4 is assigned to worker 2. This inequality ensures that if worker 2 doesn't do job 4, then worker 1 cannot do job 2. It's a reciprocity rule. Then, once we've set all the constraints, all the conditions, either for the GAMS code and also for the mathematical model, we write the final part with the model, the name of the model. All means that the heavy writings must be read by the program. We put the 2 conditions that optimize the model, so the name of the model, point OPTCA and OPTCR, equals to 0, solve the name of the model using MIP, mixed integer programming, because we have binary variables, and maximize zeta. That's it. Thank you for watching. We will see you in the next video.